Welcome back everyone to another Mythfall devlog. This week I'm doing weapon rework. So I'm going to go through all the weapons and try to make them a little bit more interesting and add more variety and different builds and stuff like that. Because I've kind of been shoehorned in a little bit based off of my current weapon system. So I wanted to rework that. That was the thing that got voted in the poll. So that's what we'll be working on most of the week, I think. And I'll try to fill out the drop tables a little bit better because I know a lot of drop tables are kind of missing interesting drops. So I'll try to make the drop tables a little bit better and add a few more items and different builds and stuff like that. So yeah, let's hop right into it. All right, first up, I reworked how the shurikens work. So before they kind of shot this like spread pattern, but now I changed them to kind of do what the scythe does, but a little bit quicker. So they can just shoot out and come back. A little bit like Sivir from League of Legends. So I think this is a fun pattern because you kind of have this range that you try to target where you want to hit the monster twice, so it has to go a little bit past them and come back. I think it's a fun type of balance, and it makes sense for something that spins like this because it's a little bit like a boomerang. So yeah, I figured I'd change this to that, make these a little bit more interesting. Also, another thing I worked on yesterday was going through and reworking how the item tooltips look. So they look a lot nicer now, and I also added different rarities to items. Let's just pick up a few different stuff. So as you can see, like the Corrupted Heart is an epic rarity. This one's a common rarity. This one's an uncommon rarity. So they're color coded for that. So that way when players get new drops from bosses, they'll kind of have some estimation of how rare of a drop they got. So hopefully that helps people understand like what the good items are and stuff like that. So, but I think this looks pretty good overall. I like how I divided it in 3 sections. So there's kind of like the title section, then there's the stat description section, then there's a little bit of like a fun description at the bottom, and then there's also like where you get it from. So some things are droppables, and I guess I didn't pick any up, but they'll tell you where it drops from. Like for example, this crossbow here is an uncommon and it drops from Pirate Cove. So all right, I think the next thing that I'm going to work on is adding a beam type weapon. So I think to do that, I want to just do a draw a square. I'll do a different color here. To do that, I just think I want to draw a square from like your player to your target, calculate that vector, and then draw a square like this, and that'll be the entire hitbox for the projectile. And I'll try to do some like effect on it where it looks more like a core that's bright, and then the edges will be kind of faded, I think. So it'll probably take multiple draws where I'll have like a core color, then I'll have a faded edge color as well, and then the green box will be the hit box. And then if there's a monster like standing right here or something, he would get hit by the beam. And I probably will just flash the hitbox for every like so often. I'll flash the hitbox for like a single frame. So that'll probably be how I implement this thing. But yeah, this was something I wanted to add for a while, so let's try to get it in. All right, so originally in Mythfall, I only supported squares and non-rotated squares for collision detection. So basically every projectile is a square, every monster is a square, which makes it a little bit hard for adding beam weapons. So to add beam weapons, I kind of need to have this like long rectangle that could be rotated because the player is standing here, he's shooting a beam out that way, and he's hitting some monster, which is like a square collider right there. So the rectangle needs to be able to check and find that collision. So to do this, I rewrote a lot of my collision detection system to make sure I could support rotated rectangles like this. And let me just walk you through kind of how this unfolds. So at the very top, I do this broad phase collision detection where I basically find the bounding box of every single collider. So for example, the bounding box of this collider, which is a rotated rectangle, would be that. And I place it into a spatial hash where these are different buckets, which are arrays that have data about the collider. So I basically place them all into these buckets. This would be like bucket 0, 1, 2. So this one will become, I guess we'll go through. This will be 3, 4, 5, 6, and then 7. So this collider would go into 1, 2, 5, and 6. And then if it ever, and then when I do the collision detection pass, I basically check it against all other colliders that are inside of this bucket as well. So it allows me to basically cull out every single collider that doesn't exist in the same kind of region of the world. So this removes a lot of extra checks that we don't have to do anymore because it only checks colliders that are nearby each other. That's kind of the first pass, is building this spatial hash of all of the collider bounding boxes. Then the second, this is often called broad phase, the broad phase. Then the next part of the collision detection is I do a bounding box check where I will basically check to make sure, like for example, if there was a collider over here, his bounding box doesn't overlap either of the bounding boxes of these two colliders. So clearly I don't have to do any more advanced collision detection for him. So I can just cancel him out if I'm checking against this red rectangle, for example. But the bounding boxes of the green one is this, and the red one is the red one because it's a square. So these bounding boxes overlap, obviously. So we have to do the narrow phase, or what's called the narrow phase collision detection. And that's where we actually do kind of an advanced collision detection algorithm to detect if these two colliders are intersecting. So how I did that, there are better ways to do it for if you only support rectangles, but I kind of decided to go with a generic polygon collision detection algorithm because I figured that most of the time I'm using non-rotated squares, and in the event that I am using rotated squares, it's not that big of a deal to lose a little bit of performance for a little bit of a generality of using a regular polygon. So this doesn't need to be a square, it could be any kind of polygon that's convex for my algorithm. And then let me walk you through how that narrow phase collision detection works. So basically, there are three cases of how these polygons could collide. In one case, we have edges that are colliding. In another case, we have one polygon is fully inside of another polygon. And then in one case, we have the other polygon is fully inside of the other one. So basically, we have to check. These two are very similar, but they're the reverse of each other. And this one I'm checking to see if green is fully inside of red. And this one I'm checking to see if red is fully inside of green. And if they are, then that's obviously a collision. And then if we ever find points that overlap, then that's also a collision. So the algorithm for this section is fairly simple. You basically loop through all of the edges in order. So you have 4 edges on this one, and you have 4 edges on this one. And you start with edge 1 here, we'll call it, and you go through 1, 2, 2, 3, 4. So 1 checks against all 4 of those. You have edge 2 checking against all 4 of those. Then you have red edge 3 checking through all 4 of those. And you have red edge 4 checking through all 4 of those. And then when red edge 2 checks against green edge 4, that's a collision. And when red edge 3 checks against green edge 4, that's another collision. So that's where there's 2 collision points, and we can find the exact intersection point. And that's just line. It ends up just unraveling into a lot of line collision checks. So that's that case. For this one, I actually had to do a little bit more Googling, but they have a clever solution for checking this. But basically, you loop through all of the points on one side, and you want to check to see if it's inside, if that point's inside or outside of the other polygon. So what they do is they just draw a line horizontally that goes infinite, and they check how many lines they intersect with on the outer polygon. So for example here, this point, we know it's inside because it only intersects one line with this polygon. But for this one, we know it's outside because it intersects with 0. And let me come up with a case where it'll intersect 2, but it'll still be outside. So if let's say the green one is the same, but the red one's a little bit more complicated of a polygon. Because remember, this is a generic polygon intersection. It doesn't necessarily have to be squares. Okay, and then just as an edge case for the other detection is the green one could intersect 2 lines for another convex polygon, and they would just intersect at these 2 points. And because it's an even number, we know that it intersected an even number of times, which means it had to have gone into and then out of the red polygon. So that's how we detect if it's the green one's inside or outside of. So yeah, that's how we check that. And this is the more advanced polygon collection detection algorithm. We only have to run this for the narrow phase. So this higher level collision detection removes a lot of extra like checks that we have to do, which saves us a lot on performance in the long run, even though there's a little bit of setup we have to do and organizing things as well. But this works pretty well as far as I've seen. So I'm pretty happy with this. There is a more advanced way to do the rectangular where you renormalize the axes, but I kind of got halfway through it and then I decided to just go with a generic polygon detection algorithm. And if this ends up being a big performance waster in my game, then I'll end up writing the kind of more complicated, it's called separation of axes, where you basically go through and check to see, you renormalize the axes for both of them just to make sure that to check to see if there's a gap between this. So you change the axes for this one to be these two, and then for this one, you renormalize it to this, and then you project these points onto the axes and see if they overlap. But I won't talk about that too much, but that's if you want to look into it for faster ways to check square or rectangles. This is how you would do that. But yeah, for polygons, this seemed to be like a pretty good way. I think there are better algorithms, but this was a easily understood one, so I decided to just go with it. But let me show you how those look. I haven't dressed up the art very much yet, but this is kind of a little mock-up I did, where basically, if you can see, I draw kind of 3 rectangles laid out however the rotation is. And then this just goes and collides as far as it can. And if we go fight some monsters, you'll see the hit detection working. So it kind of just hits like that. If I turn the debug on, you can see the hurt box, which is the green squares for players, and this red inner box is the hit box for the beam. So you can kind of see how I can hit. It's a little bit blurry because there's so many things on the screen, but you can see how the collider rotates with the square, and it looks pretty good. I can turn that off. So yeah, I'm pretty happy with how this turned out. It took a few days to get working fully, but yeah, I think it is worth it because I think it's an interesting weapon type to have. So I'm happy with it. But I might change it to be a little bit less constant and shoot a little bit more like a projectile. But basically, what I do is I render a new projectile every single frame and check to see if it hits anything. So as you can see down here, the cooldown bar just kind of flashes because it's constantly shooting because there is a like 0 cooldown. So one of the new features that I wanted to add to differentiate daggers from other types of weapons like swords was to add a new backstab mechanic. So now there's a backstab damage bonus that you get for most daggers. Some of them don't have it, like the stick is considered a dagger, but it doesn't do any backstab damage. But basically how it works is you can see the direction that the different mobs are pointed, and they decide which direction they're pointed based off of who they're targeting. And these ones always just point to the right because they don't look for targets, but most mobs will target the nearest player. And so how it works is basically if you're shooting the back, you'll see a little red dagger there popping up next to it. You'll get a 20% damage boost. But then this one, you see I did less damage and I don't have the little red dagger. And then it scales with your damage and your strength. So if you have more strength, like if I max my character, now I'm doing 20 damage with backstab bonus, and I'm only doing 17 without it. So it's a nice little 20% damage boost if you can position yourself in the right spot to get behind the monster. And I think it'll also open the door to add some sort of like invisibility mechanics so that you like lose aggro, so that the mob will target somebody else and you can kind of sneak behind them. So yeah, I think this is a good start to that sort of stuff. Along with adding the different item rarities, I also wanted to make it so that when you defeat a monster and he drops some item, depending on what rarity the item you get was, it'll change what the chest art looks like. So I basically went through and did a few mock-ups of different chest colors, and I kind of just lined them up with the different rarity levels. So there's this is common, uncommon, and you have rare, epic, legendary, and mythic. And then maybe I'll use red for something else, or I'll change one of the colors in the future. This is what I ended up landing on. So depending on what item you get from a monster drop, you'll get a different chest sprite to show kind of what level of item you're going to get from the drop. The next thing that I wanted to work on was improving how stabs work. So right now, stabs didn't scale with any particular stat. Like there's different character stats that you have, but I decided to change them so now they scale with your willpower level. Let me just equip one. You can kind of see it does like 6 damage. If I max my character, it starts doing more damage. I also added a few different other types of wands. So this is a bubble wand that you get from one of the earlier biomes. This one's called the spore wand. So it kind of explodes and shoots a lot of different projectiles. And I added a beam weapon, which is called the focusing rod, and that shoots like this laser beam type thing. And because I know people are going to want to know what it looks like with a crown. When you shoot with the beam weapon and a crown, it basically does like a double beam in parallel. Originally, I was going to do the fanned shape, which I use for most of the bow weapons, but I decided to go with this just because the fan shape is so unusable. I also had this nice little testing arena, so you can kind of test your DPS. And I added a DPS tracker too, so now you can go and do a little build and test your DPS to see like how effective it is and stuff like that. So yeah, I think it works pretty well and pretty happy with it, I think. In addition to all of that, I also added a bunch of new weapons. So I added a new great sword called Grimm's Cleaver. I added a new bow called the Hollow Bow. This one shoots parallel. I added a new status effect to crossbows called Fractured. So now they'll break the monster's armor and it'll decrease the armor of the monster. I added a new pistol class for pistols. This is the Graviton pistol. Then I added a new cannon class for like launching rockets. This one is a pirate cannon, or I call it the shoulder cannon. And I also added a lava shooting cannon called the slag cannon, which applies a burn status effect, as you can see, which will do damage over time. Anyways, that's all I have for this week. As always, an absolutely massive thank you to all the supporters on YouTube, Twitch, GitHub, and Patreon. I hope you enjoyed it, and I'll see you next time.